second.
So the only way to win is to eat two of them.
You can't play.
Well,
Okay, we got about 30 seconds left.
it was in here though.
You can't eat one. Wait till they're finished and then eat one, okay? Wait till we're finished. Don't eat them. Don't look at me. No four ones.
And we have a winner!
Yeah, we want some M&Ms.
As you can see, wireless at VT was a lot of fun and a huge success. It wasn't all fun and games. We did actually get some work done. The farthest reaching initiative was an agreement to write an MOU between AHA, Virginia Tech, Edis Research, and AMSAT in order to work on RFNoC blocks of AHA's DVB-S2X implementation. There has been progress on this over the past week. There will be a meeting June 22nd to review the MOU and set a date for the RFNoC Hackfest. This will help the payload team tremendously. The goal is to have the forward error correction done by the GNU Radio Conference in September. The payload team wants to present at GNU RadioCon, and Phase4 ground is applied for time at DEF CON. Since last week, we started looking at LDPC blocks in GNU Radio and writing down notes. Ron Economos, W6RZ, is the author of the DVT module in GNU Radio. I asked him some questions about his blocks, and he not only answered them fully, but also said he'd be happy to complete the DVB-S2X functionality in the LDPC encoder in the DVT module. Cool. Thank you, Ron. Now, you're probably thinking, well, we have an encoder. What about a decoder? Ah, well, you're right. We'll need a decoder. We'll need to try to get it into RFNoC, and in addition to that, we'll need a whole pile of other things. But progress here should be celebrated. Please go read how to make an out-of-tree module in GNU Radio. We need people that can code in Python and C++, and we need people that can code in Verilog or VHDL to convert blocks into HDL so that they can become RFNoC. A link to this tutorial is in the notes. Another big step forward in Virginia was the successful preliminary design review for the Phase 4B payload team. This was a few days before the conference, but I had an opportunity to attend the regular Friday meeting in person and talk about how the review went and about the next steps. As mentioned last week, a sanitized version of the slides is said to be forthcoming. There was a follow-up meeting on Tuesday, but I'm on jury duty and missed it. Shifting gears to another continent, we have reached out to AMSAT DL, or Deutschland, about the Phase 4A payload and whether or not we can support their downlink with our Phase 4 ground project. The contact was positive, and more discussion will occur. Here's a technical brief about the SHAIL Phase 4A project. This payload will not be visible from North America. If successful, a payload further east, visible from Japan, will possibly be launched to join the first, which will be over Europe and Africa. Supporting these payloads increases our market and opportunity for technical collaboration with amateurs around the world. So, at this point, if you're reading along in the notes, you'll see the technical brief. I won't read it out loud. Go check it out. There's some links to YouTube videos and BATC streams, archived streams, where this project is discussed in more detail. As you can see from the technical brief, the uplink frequency is 2.4 gigahertz, and that's different than ours, which is 5 gigahertz. 4A uses a commercial DVB-S downlink. Commercial company is building this payload. 4B uses DVB-S2X. S2X is backward compatible with DVB-S, but anyone who's ever worked with backwards compatible systems knows that this doesn't just happen. It takes work and care. 4B, that's us, uses generic stream encapsulation. 4A, it looks like they're using one MPEG transport stream. The generic stream encapsulation is something that was introduced with DVB2. So the 4B downlink is hoping to use up to 10 megahertz. The 4A is 8, an 8 megahertz downlink. And if you follow the links in the 4A notes, the technical brief, then you can also see that there's a list of suggested hardware that's discussed in these presentations. These suggestions may also work for us. There's a page or a site that talks about how to modify a cheap LNB. That's in French, but the link is in the notes. Then there's SR systems with DVB-S, demodulators, and decoders. This is some nice commercial gear. It seems to be designed to get the MPEG transport stream and then decode it to audio and video. Now what we're after is something a bit different. We want to use GSE, like I said. The MPEG transport stream is just that, a transport stream for television signals. And GSE is designed to encapsulate IP traffic. Our traffic is mixed modes, voice memo, documents, text, data, video, whatever, that can be transported, IPv4, IPv6, whatever. So I wrote off to SR Systems and asked if these products support GSE, and the response seems to be yes. If you have GSE encapsulation, you can set the modulator from SR Systems to BB frame only. That means baseband frame only. And then you connect your GSE stream over the ASIN on the Minimod 4. Okay, so I'm going to follow up with them to find out if my understanding is correct. Phase 4A people are also working on a dual band feed. This would be 2.4 gig up, 10 gig down. Their primary concern is that there's a 10 watt, potentially, uplink amplifier sitting right next to the downlink LNA. They don't have the same second harmonic problem that we do, but this sort of dual band feed is still challenging, and they are calling for volunteers to help out here. Other gear discussed includes the 3 centimeter down converter from Kuhn, the MKU LNC10 with an intermediate frequency of 70 centimeters. Some stats are in the notes, and it seems to only have 2 megahertz of bandwidth. So my feeling is that this is being recommended for maybe a linear transponder. There is linear transponder packages included on the 4A. Then there's an X-band low noise amplifier from Kuhn, the MKU LNA 102S EME super low noise preamp, and it's got a frequency range that can accommodate us. It's 10.318 to 10.418 gigahertz. Hey, 22 dB of gain, 0.7 noise figure, had waveguide in, SMA out, milled aluminum case, 240 euros. Yes, please. Looks awesome. Then there's a nice 60 centimeter dish that was mentioned from Procom. I'm sure a lot of you are familiar with this. It's got 31 dB of gain, a 4-degree beam width, and the model number is in the notes. Then some details about the spacecraft were talked about. Phase 4A spacecraft EIRP is assumed 30 dBW with 50 channels, and they're expecting then 12.5 dBW per channel. And like us, they're assuming a 205 dB path loss. The ground G over T is 14 dB per Kelvin, and a C over N no of 50. So channel bandwidth is 2.5 kilohertz. That means, well, 15.4 dB carrier to noise per user. These numbers are from their presentations, and they're in line with the assumptions for us. All of these numbers made sense to me. Phase 4A will use a linear horizontal downlink polarization. This is good because we're using a linear polarization as well. We haven't picked whether it's horizontal or vertical, but their choice of horizontal may be well worth following. The emphasis for Phase 4A on education is very much in line with the emphasis on education for Phase 4B. That the justifications between the two projects align should surprise no one. This is amateur radio. There was discussion in the video about user population and how many users could be accommodated by the linear transponders as well as the wideband digital channel. The number of people beneath the footprint of 4A and 4B, for that matter, is very large. The way that people will access the satellites is really kind of unknown. 4A is making guesses and using previous experiences to try to make estimates, but it was emphasized in the videos and in discussions from 4A, and we've said pretty much the same thing, that we just don't know how many people will use the satellites. We're hoping lots. but making very sure we have good gear available and really kind of talking about what best operating practice means. These things are key. There will be a dedicated AMSAT Earth station in Doha for 4A. There will be video transmitted on the uplink from Doha in order to test ATV reception, amateur television reception, using DVB-S. But at some point, operators will uplink their own video. The decision is not to have people connect to the Earth station over the internet and then transmit ATV up to the satellite. This was discussed. The point of 4A is for operators to connect directly, learn DVB, learn ATV, and do it themselves. Peter really wants the Space Symposium in 2 years to be directly transmitted through the satellite, and if all goes well, that's going to happen. All right, there's been a big dish donation. Some fun news here. There's a 5-meter dish that AMSAT is helping provide some 501c3 paperwork for. It's aluminum and beautiful. The surface is rated to 18 gigahertz. Probably will work fine all the way up to 24 gig. It's made in Germany. It was shipped to Dallas, then never used. Very, very thick rolled aluminum. Heavy, no mount. Big bucks to transport and mount. Chuck Clark, AF8Z, is interested. It would make one heck of a ground station. Other things that need some time and attention are recruitment and solar power for the Dixon Lake equipment. This is an installation that's supposed to talk to Palomar Mountain so that we can demonstrate Phase 4 ground. And in between jury duty and some of the other things that are going on, I've talked about recruitment and I've talked about solar power and I've written a few emails, but I don't have anything to report yet on this. But I will. Another thing that needs to happen is the website. We have a little website that we're working on. This needs to be reviewed and published. So I'll try really hard to get that scheduled. I'm looking for someone to kind of take it over and do the review and run with it. And if you're that person, please speak up on the list or write me directly. I'm back on jury duty tomorrow. Pick something, work hard, try something new. Join ARRL, TAPR, or AMSAT, or all three. If you know someone that would enjoy this project or might want to volunteer, then let them know. All right, see you soon.